So we got the slope part down. So we're going to be working the slope, taking it a step farther, and writing equations of lines based on different bits of information that we have. So most of the time we're going to be given a slope and a point on the line, and we can write an equation. So starting with our first form is going to be slope-intercept form, which I think is probably really familiar to you guys. And I want to set up exactly where this point or where this slope comes from. So let's say we know two things. Let's say we know the y-intercepts, and then let's say we know any other point on the graph. So let's pick this point right here and draw a line through it. Okay, so this point, since we know it's right on the y-axis, we know that it has an x value of 0, and then let's use b for the y value. We've always used b for the y-intercept for some reason. And then let's give this a generic, just xy. Okay, so any x value, any y value, doesn't matter. So we're going to be finding the slope in between those. So slope formula that we know is y2 minus y1 over x2 minus x1. And we can set that up using the values that we've got so far. Okay, so y2, the second y value, we're just writing it as y, minus, and then the first y value is b, over x2, which is x, minus this first x value, which is 0. Okay, so we've got that set up. So if we simplify this up a little bit, the numerator is still y minus b. Those aren't like terms, so we can't simplify them at all. And then the numerator, since we've got x minus 0, we can write that as just an x. Okay, so now let's clean this up a little bit. So we're going to solve the equation for y, because we're used to having y by itself. So the first thing we can do is multiply both sides by x. So it'll cancel here, because this is being divided by x, then we multiplied, so that cancels out. So we have mx on the left-hand side, and then we have y minus b on the right. So remember, my goal is to solve for y, to get it by itself, so I'm going to add b to both sides. Okay, so when this cancels, I do get the y by itself, and then on the other side of the equation, I have mx plus b. So that is slope-intercept form of a line. I'm sure you guys have seen that many, many, many times. So if it's written in that format, like I said, we call it slope-intercept form. So let's take a look at this first example. We've got two different things that we could look at. First, if you're just given the slope and given the y-intercept, it's a little bit easier, and the second one will be given 2 different points. So if you're just given the slope, you know that that's b. That's your y-intercept that can just go right into the equation. And if you're given the slope, that is m. So this is actually about the best scenario here, is if you're given the slope and you're given the y-intercept, then you can just plug it all right in. So we are going to plug in y equals m, which is 4/3, x, plus b, which is 4. Okay, so that's your equation. It's that easy. This is the slope that it has. This is the y-intercept that it has. In your final equation, x and y should always be written as x and y. They should be the variables that you see in your equation. Okay, the next thing that could happen is if you're given 2 different points. And so if you're given 2 points, think back to what we did in 2, 3. You can find the slope between them, then do what we just did here. Okay, so if we find the slope between them, we set up m equals, so this is x1, y1, this is x2, y2. So y2 is 10 minus x1, which is negative 6, over x2 is negative 4 minus x1, which is 0. Okay, so remember, this turns into plus a positive, so we've got 16 in the numerator, and then negative 4 in the denominator, and 16 divided by negative 4 leaves us with negative 4. So that's our slope. And then if you look closely, this is actually our y-intercepts. Just like this one was here, just like this one here. If you have 0 for x, that means that this is your y-intercept. So my y-intercept is negative 6. Okay, so now I have my slope, I have my y-intercept. I can plug it into this form, just like I did with part A. So y equals m, which is negative 4, x, and then plus b. So instead of writing plus negative 6, I'm just going to write minus 6. And that is the equation I get for part B. Okay, so that's slope-intercept form. Again, you can do it one of 2 ways. You can either be given the y-intercept and the slope, or you can be given the y-intercept and another points. So if we're given anything else, any other scenario, we want to use what we call point slope form. And so I'm going to set up exactly how that one works. Let's say you're just given two random points where one of them isn't the y-intercept. Okay? Looks something like this. So let's say you've got that same point y. Remember how in this picture right here, we just called our second point just xy. Here, instead of having my y-intercept, I'm going to have a different point. Okay, so my form looks like this. Say I had some different point for the first y value, and then again here, say I had some different point for the first x value. This one, in order to clear out the denominator here, what I do is I multiply both sides by the whole denominator. I'm going to do it over here as well. So it would cancel right here, and I end up with y minus y1 equals m, which I have right here, and then times, in parentheses, x minus x1. So this is known as point slope form. Point slope form is really, really useful if you don't know what the y-intercept is, but if you have two different points. Okay, so you've got two different coordinates, and then m, of course, is the slope, just like it always is. And you'll have y and x will just stay y and x. I'll show you exactly what I mean with this one. So say you've got a point, and so that's going to be your x1, y1 in the formula, and then they give you your slope, which is m. Okay, so we want to get it back into slope-intercept form. This is just kind of an easy trick to help us get there. So we write y minus, and then for y1, it's a -2, equals the slope, which is -3/5, and then in parentheses we write x minus x1, which is 5. Okay, so we're eventually going to get into slope-intercept form. We just need to do a little bit of simplifying first. So distribute this -3/5. So first I multiply it just by the x, and then I have -3/5 times -5. So first of all, this 5 will cancel with this 5, and then negative times a negative gives me a +3. And on the left-hand side, I have y. I'm going to write this as plus a positive, so it's y plus 2. And I'm just one step away, because y equals mx plus b just means I need to get the y by itself. So I can subtract 2 from both sides. We're left with just a y, just like we wanted, and then we have -3/5 x, and then +3 minus 2, use it with +1. So that is your slope-intercept form that you're looking for. And you can see how this is the slope? It should be the same slope that you've got right here. Nothing should have changed. Okay, last example for this video, we're going to look at a standardized test example, so looking at some multiple choice options. So one of the big things that you can do while you're taking either the ACT or SAT is look for things that you could eliminate. So you see here we've got two different slopes, and then we've got 4 possible different y-intercepts. So the first thing I'm going to do is have you calculate what the slope would be between these two, and then you can eliminate some answers right off the bat. So slope is... Oops. So subtracts, we've got x1, y1. Sorry, I was just starting to write out the points again for some reason. So y2 is -4 minus y1, which is -9. x2 is 2 minus x1, which is 4. So change this to plus positive. So I've got -4 and a +9, that's 5, over 2 minus 4 is -2. So my slope is 5 over -2. So this is the slope I'm looking for. So that means this one's out and this one's out. So already I've got it down to 50-50. So again, if you were taking a standardized test, you could at least give yourself a fighting chance for a guess. So next, you've got a couple options. What I would probably just do is set up either one of these points into our point slope form here, okay? So I'm going to do y minus, and you can just pick whichever one you want. Like if this one looks like better numbers or if this one looks like better numbers, either one is fine. So I'm going to do this one just because these numbers are a little bit smaller. So pick your point. So y minus the y value, so minus a -4 equals, and then you can plug in the slope, -5/2, and then in parentheses you do x minus your x value. So our x value here is 2, so plug that in. Make sure if you pick one of the points, you have to use this x value and this y value. You can't mix and match from the two. So simplify this up, distribute -5/2 times x, and then multiply these two together. First of all, the negative times negative is positive, and these 2's will cancel. So it'll leave you with 5. And then this is y plus 4. So last step here to get the y by itself, you'd subtract 4 from both sides, and then you can see this is going to leave you with 1. Positive 1, not negative 1. So that's how you would end up choosing A. All right, so that's it for the first half.